Hello everybody, we're back today to talk about linear functions. And just what is a linear function? What does it describe? Well, the name actually tells us what it is talking about. The word line is in linear, so we're talking about a function that actually describes lines, okay? So when we think about lines, we've got a couple of characteristics that we need to think about, okay? And one of those is, how is this line moving, okay? So this line here, and it's important to show that a line has these arrows because that implies continuation. A line is infinite. It goes on forever in all directions. So when I look at this line right here, the one thing that I notice is how this line is angled on this graph, right? Or how it is changing, if you will, okay? So if I look at as my line moves along the positive x, it's also moving along the positive y, isn't it? So I'm talking about this change here that's going on, all right? And what this change can be referred to is slope. It can be referred to as pitch, and it can be referred to as a gradient, all right? But the important thing to think about this slope here is this term here, rate of change, okay? So we're using a function and its graph to illustrate how an event is changing as it goes on, okay? So I know that as I move this distance to the positive x, I'm going to move this distance to the positive y. And we're going to use the little letter m to indicate slope, okay? Slope is going to be the term that we're going to use relative to this line. And slope is defined as y2 minus y1 over x2 minus x1, okay? So where did those terms, values come from? Well, let's look at this point and this point. If I call this guy P1 or point 1 and that guy P2 or point 2, point 1 is going to have the coordinates x1, y1, and point 2 is going to have the coordinates x2, y2. So when I'm talking about y2 minus y1, I'm referring to this change that is occurring from here to here in the y direction. x2 minus x1, the change that is occurring from here to here in the x direction. And you'll see in some places where they're going to say this delta, this triangle, delta x over delta y. Delta just simply implies change, okay? It's a Greek symbol. So what I want you to also realize that's important about slope is whether I'm going from left to right or right to left, notice that line didn't change, and I shouldn't expect my slope to change, okay? So let's just pretend that P1 had the coordinates 4, 1, and P2 had the coordinates, let's go 10, 6, okay? So if that's what P1 is and that's what P2 is, the slope is y2, which comes from here, 6 minus y1, okay? all over x2 minus x1. And that's going to give me what? 5 over 6, and I can't reduce that any. Okay, now again, I pointed out that slope does not change depending on the direction I'm going. So and that's good because this just depends on how I label things, right? What if I had said P2 was the point 4, 1, and P1 was the point 10, 6, right? I mean, I could have called that P1 and that P2 just as easily as I did what I did. So let's look at slope here. All right, so y2 is 1 minus y1, 6 over x2, which is 4, minus x1, which is 10, right? So I get minus 5 over minus 6, or I still get 5, 6. And that's important because, like I said, this is just about how we're naming it. That line did not change based on what we were doing, okay? So again, slope is rate of change, how y is changing over how the change in x, okay? So let's look at a couple of special cases here. Let's look at a horizontal line, okay? So if I have a horizontal line on my graph, and let's just say this horizontal line was down here, okay? Now, notice it's parallel to the x-axis, right? So that means for a horizontal line, this distance down to the line, right, is going to be the same y at every point, isn't it? Y is always the same. The only change I have is x. So if I look at my slope in terms of the change in y over the change in x, well, if y is the same everywhere along there, I'm going to be subtracting a value from itself. If this happened to be minus 8, up here I would have minus 8 minus a minus 8, or a 0, wouldn't I? So it doesn't matter what's in the denominator because 0 divided by anything is always 0. So for every single horizontal line, we will always have a slope of 0, okay? That's for every single one, no matter where it is. So that's one special case. Well, what happens if we have a vertical line, okay? Let's look at what's going on with a vertical line relative to slope. So if I have a vertical line over here on my graph, we have a similar situation. It's parallel to the y-axis. Every single point along this line is going to have the same x value, okay? Y is changing for sure, but x is the same everywhere along here, right? So what's going to happen here? Well, I'm going to have this change in y over change in x because that's the slope. The change in x from this point to this point, x is the same. So again, just like I had up here with the y's, if I subtract something from itself, I'm going to get 0 in the denominator. And it doesn't really matter what's in the numerator because anything divided by 0 is undefined. Okay? So for every vertical line that you have, and it doesn't matter where it is in the graph, all vertical lines are going to have a slope that's undefined, okay? Always. So that's something really important to remember. Horizontals, slope 0. Vertical, slopes are undefined, okay? So we've got another important thing to talk about here, and that happens to be something called the slope-intercept form of a line, okay? Now, many of you have probably seen this in some way, and that is y is equal to mx plus b, okay? So y and x are the variables in your equation, and we know that m is the slope, and this b here is what is known as the y-intercept, okay? And what is the y-intercept? It's where the line crosses the y-axis. So here's the y-intercept for this line. Here's the y-intercept for this horizontal line. And notice the vertical line does not have a y-intercept, okay? So when I'm looking at this, I can pull information from that equation. If I have the equation 6x plus 4y is equal to minus 2, okay? How can I know anything? Well, I can't yet until I get it into this equation form. So I'm going to subtract 6x from both sides, and that's going to leave me minus 6x minus 2. Notice I put this 6x in front because I'm always building towards that format, right? Now I'm going to have to divide both sides by 4. So that gives me y is equal to minus 6/4 x minus 2/4. And of course, we always simplify. So that's minus 3/2 x minus 1/2, okay? I can graph this line without knowing any other coordinates, and let's see how I can do that. All right, so here's my graph. There's 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, okay? Now, we've talked about this. This y-intercept is always going to have the coordinate associated with it of a 0, comma, b, isn't it? Okay? Because in order to go through the y-intercept, the y-axis, it has to have an x of 0. So when I'm in y equal mx plus b format, right there is a coordinate. It's 0, comma, minus 1/2, okay? So 0, comma, minus 1/2 is on my graph. So let's put that guy on there. Over 0, down 1/2, okay? Now, here's my slope, right? So m in this case is equal to minus 3/2. All right? Well, remember, that's rise over run. That change in y over the change in x. Two of my favorite words in all of math, rise over run, because it has such a powerful meaning when we're doing algebra, okay? So what that says is for every change in 3, I have a change in 2. But I need to be just a little bit more detailed here, and I can think of this as minus 3/2, and I can also think of this as 3 over minus 2. This just gives me options in terms of which direction I want to graph, okay? So let's take this one, 3 over minus 2. So I'm going to rise 3, 1, 2, 3, and then I'm going to run minus 2, so 1, 2. So all the way out here is going to be that point, okay? So this point here is what? Minus 2, and then 1, 2, 2.5. Remember, we always label our points. I could have used this one, okay? This had a rise of minus 3, so 1, 2, and then halfway after this would be right about here. And then a run of positive 2, so 1, 2, so maybe somewhere out in there. And look, depending on my artwork, I'm going to be able to draw this line. And in this point here would have been 2 comma minus what, 3.5. Okay, so I can break my slope down into rise and run. I didn't have to go calculate any points. I could draw my graph. Now, what would you do if, say, I had something where I said, well, the slope was equal to 4? What do you do then? Because it doesn't look like rise or over run. Honestly, though, it really does, because any integer is, in fact, a fraction. So this slope would have a rise of 4 and a run of 1. Another way to look at that, though, is also a rise of minus 4 over a run of minus 1, because 2 negatives will cancel out there, right? So you've got options again, just like you had options here. And that's important to know, because what if your point is way up here at the top of your graph? You need a slope with a negative rise, don't you, in order to just fit it on your graph. So that's how those kinds of things are going to work. So let's look at some more examples here. Let me say that I have a horizontal line and a y-intercept of 6, okay? What's the equation? Well, what do I know here? Well, if it's a horizontal line, I know that my slope is 0, right? I know then that my b is equal to 6. Let's put it into our formula. So y is equal to 0 times x plus 6, or y equals 6. So a horizontal line will always have an equation, y equals something, and that something is the y-intercept, right? Because notice back on this other horizontal line, x is constantly changing, so it really doesn't matter what I'm talking about here, because if this happened to have been minus 10, then every point here is some x, who cares, minus 10, right? So we'll call this point here minus 10. Likewise, for a vertical line, the y is constantly changing, right? And let's say this guy was out here at, I don't know, minus 12. Notice how the x always stays the same. So if I had a vertical line, I'm not going to have a y-intercept, am I? I'm not going to have a slope. So all I need is whatever x is. okay? Because again, looking at my graph, that's all that I have here. So x equals minus 12 for that horizontal line. I'm sorry, for that vertical line. For my horizontal line, the equation is just simply y is equal to minus 10, okay? So vertical lines, x equals something. Horizontal lines, y equals something. And then that's how I can go about graphing it, okay? So let's see, what are we going to talk about next? We talked about graphing. So the general form of a line, general form of a linear equation is simply going to be this ax plus by is equal to c, okay? So just like we did on this problem over here, ax plus by equals c. And when we want to graph them, we take the general form and we convert it. We want to convert it to the slope-intercept form, okay? Because just like I showed you, we can graph from those, okay? Now, something else to be thinking about. In order to graph a line, I need 2 points, don't I? But what if all I have is 1 point? And I have a slope. Let's say I have a slope of m that's equal to minus 2, and I have a point here, 1 comma minus 4. There is a way from just that information to calculate the equation of my line, okay? And there's an equation, and it's called the point slope form, okay? And we're going to figure out what that is. So let's go all the way back to my original equation for slope, okay? So for slope, I have to have 2 points. Here's point 1, here's point 2. In this example, all I have is just a slope and 1 point. So this second subscript doesn't do me any good there, does it? Because I don't have a second point. So if I just forget about that, it makes my equation look like that, doesn't it? So just using normal algebra, I would multiply both sides by my denominator, and that would cancel out this denominator and move this over to the other side, wouldn't I? So here I have mx minus x1 is equal to y minus y1. Okay, now I can put in my values because all I need here is 1 point and the slope. So I have minus 2 times x minus 1 is equal to y minus this minus 4, okay? So I'm going to distribute. So minus 2x, this is going to be plus 2. This is plus 4. I'm going to subtract it from both sides so that I have a y, because again, I'm trying to get into y equal mx plus b format. And then that's going to allow me to say y is equal to minus 2x, and then 2 minus 4 is minus 2. So what do I know about this? I have a slope of minus 2, which is what I said I had, and I have a y-intercept of minus 4, okay? So the point slope formula takes the slope times this x minus x1 and this y minus y1. Now, it's important to keep in mind that this x and this y are not points. They are the variables that you're going to end up with in your equation, okay? So here's your point slope formula that we derived by just talking through with some common sense here, the slope formula in order to get that, okay? So you can use that to develop an equation. So here's our tried and true example. Let's say I have 2 points, -6 and 8. And how about 10 and -4? Give me the equation of the line. All right, so what do? Well, first thing, you can never go wrong by getting a slope. All right, so let's just calculate slope. So m is equal to, and again, remember, it doesn't matter which point I pick first, but just so I don't make a mistake, I'm going to call him point 2 and him point 1, because that's one of the most common things. I see people intermix these things, all right? So y2, well, that's -4 minus y1, which is 8, over x2, which is 10, minus x1, which is -6, right? So here I'm going to get a -12 all over 10 plus 6 is 16, or I'm going to have a -3/4, okay? So now that I've got a slope, well, guess what? If I think about my point slope formula, I needed a slope, I just got it, and a point. Well, I actually have 2 points to choose from here, don't I? So I'm going to write my formula down here. X minus x1 is y minus y1. And then I'm just pick one. I mean, you could either one. It doesn't matter. So let's say m is 3/4. We'll pick 0.1. X minus x1, which is my -6, is equal to y minus y1, which is 8, right? So I get -3/4 x. Now notice I've got minus times a minus times a minus, so I'm going to end up with a minus, right? And here I'm going to have 6 times 3, or 18 over 4. And I'm going to add 8 to both sides so that I get y. So -3/4 x. So I have -18/4 plus, I got to combine these, right? So 8 is 32 over 4, which is y. So -3/4 minus, plus 32 minus 18 over 4 is y. I've got my x, -3/4 x plus, what do I have here? 14 over 4 equals y, and -3/4 x plus, and this happens to be 3 1/2 is equal to y. And I can graph that, right? So I come over here and I look at, well, my y-intercept, 2, 3, 4, is it positive 3.5? Okay, and then come down here and look at my slope. M is -3 over 4. Well, that's -3 over 4, or 3 over -4, isn't it? So I've got options. I don't want to pick this one because it's going to go off of my graph, isn't it? So I'm going to use this guy and I'm going to rise -3. So 1, 2, 3, and then I'm going to run 4. 1, 2, 3, 4. All right, so I'm going to come right through here, and now I have my 2 points. I can connect them and end up with the graph of my line, okay? So something I want you to notice here, when I have a positive slope, like I did in this very, very first example, when it's positive, see, I've got an increase going from left to right. When I have a negative slope, like I do here, I'm going to be decreasing as I go left to right, okay? So characteristics that you need to be aware of, because that will help you check your work when you're going through all of this, okay? So just a few more things to wrap up on this lesson, and those are the topics of parallel lines, and perpendicular lines, okay? Because there's some properties here that we need to know. When I have parallel lines, all right, let's look at that on a graph. So I have 2 lines here, right? And they're both proceeding in the same directions at the same angle, right? The distance here and here is the same as the distance here and here. These lines never get closer when they're parallel, all right? And you'll sometimes see the symbol, these 2 slashes, okay? So when 2 lines are parallel, they're moving at the same clip, their slopes are the same, aren't they? Their slopes are the same, but the only thing that's different is their y-intercept. So their y-intercepts are different. Okay? So let's put a perpendicular line on here. And if I look at a perpendicular line, it's going to come down here just like this. The important thing about a perpendicular line is it forms this 90-degree angle, okay? So this is perpendicular to that original line. And you're going to see the symbol this used for perpendicular lines. So when I'm talking about perpendicular lines, the slopes, if I'm going to call this line M3, this guy was line 1, and this was line 2, all right? So the slope of line 3 is equal to the negative reciprocal of line 1, okay? So perpendicular lines have negative reciprocal slopes of one another, okay? Do not say opposites, because that is too general and does not tell us what we need to know. So if I had a line y is equal to 4x plus 2, and I asked you for the slope of a line perpendicular to that line, well, you would say my slope here is 4, so the slope of the perpendicular line is, well, I'm going to take the reciprocal, right? I'm going to flip it, and then I'm going to take the negative of it, okay? So sometimes you're going to get questions, find the equation of a line that is perpendicular to this line and it also passes through another point. Okay? Well, all you have to do is take the line they give you, find the negative reciprocal of that slope, and then do the point slope formula in order to get the equation of your new line, okay? If I were to have asked for a line parallel to this, I'm going to use the same slope. I'm going to use that new point, and the only thing that would be different would be what? My y-intercept. Because just like I showed here, everything else is the same except where they cross the y-axis, okay? So we talked about a lot of things in this lesson and how linear functions, the name tells you what we're talking about. We're going to talk about lines, okay? We talked about slope. That is so important in describing a line. It's this rate of change, and it's y2 minus y1 over x2 minus x1. Horizontal lines have a slope of 0. Vertical lines have a slope that's undefined. Horizontal lines are always going to be of the format y equals, of course, the y-intercept. And a vertical line is always going to be x equals something. We talked about the general form of an equation, and we want to convert that to that slope-intercept because that is what is so important in dealing with these lines, okay? And there's my slope-intercept equation form. We figured out how to get the point-slope form because this is so helpful in getting us an equation because all I need is a slope and one point, plug it in, and then you can calculate what's going on. We looked at moving from the format of the general format to graphing from here and how I can look at this term in two different ways, right, to make it easy to put onto the graph. And then we looked at what an integer becomes in order to graph that as well. So, and then we went through an example where we start off with 2 points, we calculate the slope, we put it into the point slope, and we work our way down till we get our slope-intercept form, and then from there I can go straight to my graph and graph it, okay? So super helpful stuff in graphing. This is something you're going to be doing in so many areas later on. It'll be just super helpful for you, but memorize that slope equation and that point slope because everything else will come off of that, okay? And that will conclude our lesson on linear functions today. I'll see you next lesson. Bye.